To edit the GCMS method, you're going to work in ChemStation. You can work offline, but it's better to work online because if you're working offline while something else is running, it can really mess things up. So you're going to go ahead and load the method you're currently working with. Do not try to make a new one straight from scratch. It's really difficult to do that. So load a method that you know works and then modify whatever you want to modify and then save it as something new. After it gets loaded, you are going to, under the method tab, click on the edit entire method. So if you watch the GCFID video, the first part is going to be just like GCFID, but then you have to edit the mass spec at the end. So you're going to click OK through most of these windows. Most of these you do not want to mess with. They'll mostly just prevent you from running. One exception is these wash solvents here on this, but if you want to see that, it's probably better to come see me. You can change the number of washes there, but generally you're going to say OK through here. That's the window for the robot. Now we get to the editing the GC. The most important part of editing the GC is going to be the oven, the temperature program. This determines how aggressively the instrument pushes the compounds off the column with heat. So you can run an isothermal program if you don't need a gradient by just sort of picking a temperature. A good temperature to pick is 20 or 30 degrees below what your temperature alluded at in the ramp, and just doing one line where you hold for maybe 5, 6, 7, 8 minutes. And if you just have one compound, this can push things out very quickly, particularly if you run it kind of over and over. But if you don't know what you have, or you're running different compounds that elute at different times, they have very different boiling points or polarities, you're going to need to run a gradient. And when you don't know what you're going to see, a gradient is a really good idea. So here we're going to say, all right, we're starting at 70 degrees. We're going to hold for 2 minutes. And you can see this changing as the red line in the plot above the table that I'm changing. So in this temperature program, I've said, okay, let's go from 70 to 150 at 20 degrees C per minute. We're going to hold at 70 and at 150. And then we'll move more aggressively to a higher temperature and really try and push everything off, and then hold for a little while at that higher temperature. So we sort of have two ramps going on here. This is similar to a Clark's method that they use, but you can really feel free to change a lot of things in here. Don't go too cold. You really don't want to go much below 70 degrees, maybe 50, but don't go too cold. But other than that, this is a really nice thing to play with, and you can dramatically change your chromatography. You're not going to change the column. That is set. The flow rate, unlike the GCFID, do not go faster here. You can really choke the mass spectrometer if you push too much gas through, so you really want to leave this at a milliminute. The inlet temperature is pretty important here. If it is too high, then you can really enhance thermal degradation of some compounds. If it's too low, you're not going to get signal for things. You can run a split or a splitless injection here. We're almost always going to run a split, at least 50 to 1. You can go lower if you're really trying to get peaks, but generally you're going to run pretty hot there. The heater, auxiliary heater, should be on. That's for the interface between the GC and the mass spectrometer. So once we're done with all this GC portion, notice there's no FID signal bar or anything like that because there is no FID on here. In terms of detectors for the GC end of things, we're just saying, okay, keep the heater warm. Just click OK. This is the mass spectrometer method window. One of the more important aspects of this is the solvent delay. You have to turn off the mass spectrometer filament. Here it's set for 3 minutes, and let the solvent elute. We do not want to see a solvent peak. That will damage the filament. So leave this at 3 minutes unless you know better. Another really important value is what masses do you want to scan? I've got it set from 40 to 500. It often goes from 50 to 500, but you'll miss some of the ammonium ion peaks for things like phenylethylamine if you're up at 50, but you can play with that. You want to make sure whatever fragments you're looking for are within that mass scan window. You can run what's substantially more sensitive if you know what you're looking for. You're going to run a trick called selected ion monitoring. You may do that in toxicology. But when we're doing qualitative analysis and we don't know what we're looking for, we're going to scan the entire range and just ensure that we get peaks. So the big thing here is the rest of this is pretty nuanced, but the solvent delay is really important. You want to leave it on. If you really need to, and you're going to click OK through this, that doesn't really matter. I generally say no. And when you save it, again, when you save method sequences or data, I would encourage you here, it can get really confusing, to go ahead and name it whatever you want, but put a little something underscore with your initials or maybe your name at the end, because it can get confusing when you have a lot of people queued up with a lot of different methods and samples, and they all have the same kind of generic names.